Hey guys, at this point we are now done with coordinate geometry. It's time to start looking at curve sketching. So, in this video I'm just going to run through a quick introduction on a couple ideas that are useful for sketching cubics and quartics. And then we're going to look at reciprocals on their own after we've looked in depth at sketching each of these two. So, these guys on their own, I'll probably have 2 or 3 videos chock full of examples of sketching their graphs, because it's a skill we need to be really happy with. So, before we get going with those then, let's just reinforce what each of them are. So we saw cubics back in the quadratics and cubics chapter. A cubic is a polynomial where the highest powered x term is a power of 3. So they are of the form y equals ax cubed plus bx squared plus cx plus d, where a is not equal to 0. B, C and D can equal 0 if they want to, but A cannot. And a quartic is a polynomial where the highest power of x is 4. So these guys can have 5 terms. Ax to the power of 4, add bx cubed, add cx squared, add dx, add e, where a, again, is not allowed to equal 0. So cubics can potentially cross the x-axis at 3 distinct points. Quartics can potentially cross at 4 distinct points. So sketching those is quite a lot of work. Now, in terms of the shape of the graph, what I like to call the boss term is the highest powered x term. So the ax to the power of n determines, sort of the shape of the graph, but more where it comes in and where it exits. Of course, the rest of the polynomial determines how many times we cross the x-axis and stuff. But to show you what I mean, if we first of all take a look at when we have an odd power of n, then we get graphs that look something like this. Now this is just a general case. Here we're only crossing the x-axis once. Of course, cubics can cross the x-axis at 3 points. So this isn't a representation of all possible cubics, or indeed all possible functions that are odd. But just to show you that when n is odd, on the left, if a is positive, so greater than 0, then our curve is going to start somewhere in the bottom left of the graph, and it's going to end up going off to the top right of the graph. So that is if a is positive, greater than 0. If a is negative, so less than 0, an odd function will start up in the top left, and it will finish going off down towards the bottom right. On the flip side, if n is even, then we have an even function. Now you're going to have some variation of either a U-shape or an N-shape. Now they're not always smooth U's or N's, because we can cross the x-axis multiple times. But it's just important to realise if A is greater than 0 here, then we're going to start somewhere in the top left, and our function is going to end going off up into the top right. Or if a is negative, so less than 0, we're going to have some variation of an N shape. We're going to start coming up from the bottom left and end going down into the bottom right. So these little bits here are really the first thing that we take into consideration before we start about sketching these graphs. So I thought it was worth mentioning in a video on its own. Now we're going to have a look at sketching cubics in however many videos that takes. So I did touch on it a little bit back when we were factorising cubics, but now we're going to look at more complicated ones. Okay guys, take care, see you there.